This video is to walk you through how to do numbers 5 through 7 on Test 2 Test Review. So if you look, numbers 5 through 7 are asking you to write the polynomial in standard form given the zeros. So let's look at number 5. You're given that x equals 5 multiplicity 2 if this thing will focus. There we go. Alright, so you're given that x equals 5 multiplicity 2 1/2 and -3. So then they want us to write it in standard form, but first we have to write it in factored form. So then 5 multiplicity 2 means that our factor would be x minus 5 quantity squared. We square it because of the multiplicity of 2. If it was a multiplicity of 3, then we'd cube it. So the exponent is directly related to the multiplicity. So then our other factors would be the quantity x minus 1/2 and x plus 3. So we always write factors as x minus the root. So in this case our root is -3, so then x minus a -3 gives us x plus 3. Alrighty, so now I'm just going to write them all out so you can see them. So x minus 5, or the quantity x minus 5, times the quantity x minus 5. And then for this factor, x minus 1/2, we will do bottoms up. So you take the denominator and put it with x. So then this factor is really 2x minus 1. And then the last one, the quantity x plus 3. Alright, so now to put it in standard form, you have to multiply these 4 factors together. So I'm going to multiply the first 2 together, then the last 2 together, and then multiply the 2 trinomials that I get. Alrighty, so x minus 5, x minus 5. So then we get x squared, -5x, -5x, and 25. So f of x equals, let's see, the quantity x squared minus 10x plus 25. And then I'm going to multiply these 2 together. So 2x minus 1 times x plus 3. So then we get 2x squared, -x, positive 6x, -3. So then our other trinomial is 2x squared plus 5x minus 3. So now I'm going to multiply these 2 trinomials together using the box method again. So instead of having a 2 by 2, we'll have a 3 by 3 now. So x squared minus 10, oop, that should be an x right there, 10x plus 25 and then 2x squared plus 5x minus 3. So we get 2x to the 4th negative 20x cubed positive 50x squared 5x cubed negative 50x squared positive 125x negative 3x squared positive 30x, and negative 75. Alright, so now let's look to see if any of our terms cancel. So we have a positive 50x squared here and a negative 50x squared here, so these two will cancel. And then the rest we'll just have to combine like terms. So then our final answer is 2x to the 4th let's see, negative 20x cubed plus 5x cubed is negative 15x cubed. Let's see, minus 3x squared. 30x plus 125x is 155x. And then minus 75. So then this is our final answer in standard form. Make sure you have f of x or y equals, because we're writing functions. Alrighty, so now let's look at number 6. So for number 6, we're given that x equals negative 3 and positive 4i. So now remember your imaginary root theorem, which says if bi is a root, then negative bi is also a root. So we have positive 4i, so we know from that theorem that negative 4i is also a root. So now when we write our function in factor form, we should have 3 factors. So x plus 3, because remember x minus a negative makes a positive, so x plus 3, or the quantity x plus 3, times the quantity x minus 4i times the quantity x plus 4i. So now I'm going to multiply the two imaginary factors together first, and then multiply what I get by the factor x plus 3. So x minus 4i times x plus 4i, we get x squared, negative 4xi, positive 4xi, negative 16i squared. But negative 16i squared simplifies to negative 16 times negative 1, which is positive 16. So then we have f of x equals the quantity x plus 3 times the quantity x squared plus 16. So now, use the box method again, x squared plus 16. Alright, so then we get x cubed, 3x squared, 16x, 48. So then our final answer, f of x equals x cubed plus 3x squared plus 16x plus 48. So this is our final answer in standard form. Alrighty, so now last one, number 7. Number 7, or last one for this video, you still have quite a few left on the study guide. Alright, so number 7, you're given that x equals 2 minus 3i. Alrighty, so now, according to the complex conjugate root theorem, if a minus bi is a root, then a plus bi is a root, and vice versa. So we also know that 2 plus 3i is a root. So now we can write our factors. And also, if you have an imaginary or complex root, because of those theorems, you know they always come in pairs. Alrighty, so to write them as factors, we would have x minus the quantity 2 minus 3i and x minus the quantity 2 plus 3i. Remember, it's always x minus the root. So then we distribute the negative, so we get x minus 2 plus 3i and x minus 2 minus 3i. So now, since it is 3 terms times 3 terms, I'm going to use the box again. So x minus 2 plus 3i and x minus 2 minus 3i. So then we get x squared, negative 2x, negative 2x, positive 4, positive 3xi, negative 6i, negative 3xi, and let's see, positive 6i, and negative 9i squared. Oops, you can't see that. Alrighty, so then negative 9i squared simplifies to negative 9 times negative 1, which is positive 9. And then let's see, do anything's cancel? We have a 3xi here, and a negative 3xi, and a negative 6i, and a positive 6i. So when you multiply the complex root times its conjugate root, your I terms will always cancel, and then you'll end up with an I squared term that will become a real number. So when you multiply complex numbers together or imaginary numbers together, in these cases, then your I term should cancel, so you should just end up with real numbers as your answer. So then let's combine like terms. So then we get f of x equals x squared minus 4x, and then 4 plus 9 is 13. So we get the real answer, x squared minus 4x plus 13, as our function from those two complex roots. So this concludes the video for numbers 5 through 7. There will be other videos that go over the other problems on the study guide.